So the question is how to find a Nash equilibrium given the SPE. So the highlighted one, so the BCCA is the SPE. So I think by now you should know how to solve this already. And so one thing that I think is very confusing is many people don't know what equilibrium path is and what's the relationship between the equilibrium path and the equilibrium outcome and the equilibrium. So a equilibrium is one strategy for each player. So one equilibrium, say the SPE, is an equilibrium. So it's B, C, C, A. So one strategy for player M is either A or B or C. And one strategy for the second player F is actually you need to specify three actions because there are three places where the player needs to specify action. So this whole thing is one strategy. It's not three strategies. So it's one strategy for player F. So a equilibrium is a strategy profile. So one strategy for each person is called an equilibrium. So equilibrium path, equilibrium outcome is when the game is actually played, what will be the outcome. So where will the game end? So here, if we start from the root, then we follow the action that they are going to choose, then we are here. So this pair of utility represent the equilibrium outcome. So the equilibrium path is the set of action that leads to this outcome. So we actually denote them the same way. So equilibrium path is usually denoted as BC, and the equilibrium outcome we also denote it as BC. We don't want to denote this as 1-0 because there are many 1-0s in many different places, so there's no way to understand what's going on if you say 1-0. So path and outcome, they are kind of the same thing, so you can denote them by the same notation. So the second thing is the important thing, how to find the Nash. So I said there are two ways to do it. So first, modifying stuff on equilibrium and modifying stuff off equilibrium. So the off equilibrium histories are these two. So we can modify the C to B or modify A to B. So I'll do the C to B part. So if I modify the action of F of equilibrium, then I want to try to change from B to C. So if the result of this change is that M will not change, then this is a Nash. So we want M to stay at B, and let's see if it's right. So the new strategy will be B, B, C, A. Then for the first person, if I choose A, I get -1. If I choose B, I get 1. If I choose C, I get 0. So -1 is not going to be chosen. B is still going to be chosen. So B is still optimal. That's why M will not change his action. That's why this is a Nash. So one Nash is specified by B, B, C, A. So that's our first method. The second method is modifying stuff on equilibrium. So we go back to the original thing. So we start with B, C, C needs to be modified. So I modify here. So C goes to A. So basically, the intuition is so the first one is I'm lying where I don't care because it will never happen anyways. That's why I can lie as much as possible as long as my lie does not affect the outcome. So the second one means I deliberately lie, knowing that this will happen. But if I lie, then this will not happen. So I lie in order to make this not happen. That's the intuition. So I'm lying. I'm saying I will choose A. I try to make the first person change. If the first person does not change, then the lie is not going to work because this will happen. When things happen, I don't want to lie. So then I am saying this. So let's see. So if I choose A, then I get 0. If I choose B, I get -1. If I choose C, I get 0. So obviously B is no longer optimal. Now the first player, well, M, will either choose A or C. So suppose he choose A, then the equilibrium actually changed, and that's what we want, right? So in the first type, we don't want equilibrium to change. In the second type, we do want equilibrium outcome to change. So, and it actually changed, so it's okay. So A, C, A, A. So those are the the two Nash we found. And of course, if you can convert this to a very large strategic form game, you can find all of them. But on the exam, you will not be asked to do that. So you will only asked to provide one example of each type of modification. So that's basically how to find Nash given the SPE.